evaluate. So it's a good practice to work on our table. So please choose whatever you want from there, and then we'll move on. Which one? 90 this. 90. This one? Yeah. Okay, very good. Good pick. We're looking at the 90 on page 619. Sine 11 pi divided by 3 times cosine of negative 5 pi divided by 6. After we do this, we look at this problem, I would like us to discuss a little bit about odd and even functions. Which trig functions are odd, which trig functions are even. Okay. So let's start with sine pi, 11 pi over 3. I have to locate the angle. It's not a big deal because I know that this is 60 degrees. So this is 660 degrees. 60 times 11. Okay, so obviously this is more than 360 degrees. So if I subtract 360 degrees, I get down to 300. So basically, the angle is 1 full complete rotation plus 300 more. And I split this to be as exact as possible. So here it is. So this is the angle 11 pi divided by 3. It doesn't matter how many times goes around the unit circle. It's not important. It's not going to change the actual sign. What type of number will sine be? Since the terminal side is in the fourth quadrant, sine must be right, because sine is negative and positive. Cosine is positive and negative. Perfect. So then now I have to identify the reference angle. The reference angle is, yes. Very good. So the reference angle is pi divided by 3. So here's how I write the answer. Sine 11 pi over 3 is the negative sine of the reference angle. And it's negative because the terminal side is in the fourth quadrant. Sine pi over 3, or pi over 3 is the largest angle. And the first number for the largest angle is the square root of 3 over 2. So that's the answer of negative the square root of 3 over 2. So we determine this piece. Now I want to determine cosine of negative 5 pi over 6. So let's take a look. So cosine negative 5 pi over 6. So negative 5 pi over 6 is negative 5 times 30 degrees, which is negative 150. Perfect. So we know where the location would be. So we will be 30 degrees shy of negative 180. So this is the angle negative 5 pi over 6. What answer do we expect for cosine in the third quadrant? Well, we know in the third quadrant they are both negative. We know that. So we expect a negative answer. What is the what is the reference angle? Very good, awesome. So we will write that cosine of negative 5 pi over 6 must be the opposite of cosine pi over 6. Why opposite? It's because of the angle negative 5 pi over 6 lands in the third quadrant. And we know cosine pi over 6. It's the second one at the top, second value at the top, so it must be negative, this negative, the square root of 3 over 2. Because sine pi over 6 is 1/2, cosine will be the square root of 3 over 2. Now we can put everything together. So now we can write, we have both. So the first one was negative the square root of 3 over 2. The second one is negative the square root of 3 over 2. So this is 3 divided by 4. And that's a simplified form of this expression. Any questions? Yes, Lauren, go ahead. Please ask. You may see something I don't.
Can't you, if it's like the angle of negative 5 pi over 6, can't you just add 2 pi to that and then take the cosine of that?
You can do that, but we haven't discussed the odd and even properties, but yes. You could. Say it again?
Yeah.
The reason is because sine is a even angle, an even function. So first of all, that's the easiest way, not to add pi to pi. So the easiest way to think about this angle is the fact that cosine, that's the next item that I was going to talk about right now. Cosine is an even function, which means cosine of a negative angle is cosine of a positive angle. So there is no need to go around and add 2 pi, subtract 2. No. So let's talk about that. It's a very good question, however. So, so trig functions are odd, even, which means symmetric with respect to the origin and symmetric with respect to even functions are symmetric with respect to y-axis and they with respect to the origin. So let me put in parentheses for everyone. Origin, symmetry, y-axis. Please remember that. Okay. So basically there are only 2 even functions. Only the functions that have only cosine in them. And there are only 2. So that's cosine of negative alpha equals cosine alpha. And cosecant, secant I meant to write. Secant of negative alpha equals secant alpha. These are the only 2 functions that have cosine in them and nothing else. Any function that has sine in it, it would be an odd function. Meaning, tangent of negative alpha equals negative tangent alpha. Cotangent of negative alpha is negative cotangent alpha. And cosecant of negative alpha equals negative cosecant alpha. So when we look at that cosine of negative 5 pi over 6, that is cosine 5 pi over 6, and there is no need to add, subtract, or anything else. Just look at 5 pi over 6, and that's what you get. Still, you get negative the square root of 3 over 2. Yes, please, right? Say it again. Say it again.
I'm just, because I was just looking at the odd.
Yes.
And then.
But this is cosine. That's
Oh, yeah,
even. This is cosine, which is from the previous problem we had cosine of negative 5 pi over 6. What do? We go this way, this way. So since it's an even function, you can always change it into. So moving forward, we can always change all negative angles based on what we're asked to determine. So let's choose another. So we can illustrate this. So choose some other negative angles, please, from this list, so we can move on. So, for example, 98 has some negatives, or 94 has some negatives. And which one? 98? Very good. This is a very important property, the odd-even situation. So please remember, if a function has sine in it, it's odd. If a function has only cosine in it, it's even. That's all you need to remember. So we chose 98 on the same page, 619. And we have sine negative 5 pi over 4 times sine 11 pi over 6. Perfect pick. Okay, so I'll start with this, and I know that sine negative 5 pi over 4 is negative sine 5 pi over 4. Honestly, I never ever determine the sine of the negative angle. It depends on the trig function. It's sine, it's an odd function. I'm not removing the negative or distributing or factoring out. Please remember, this is sine of a negative angle, which is the opposite of sine of the angle. Now I have to locate the angle. This is the easiest angle to work with because pi over 4, there are 2 here, and another one. So that's the easiest way. You don't have to calculate. You don't have to multiply. There are 2 pi over 4 in each quadrant. 2, 2, and 1. And that's your 5 pi over 4. So then the answer, it's negative because of this, and also it's going to turn into positive because this angle ends in the third, or has the terminal side in the third quadrant. So the reference angle is
pi over 4. So this will be negative sine. Yes. With a negative in front, will change into positive. So let me not confuse you. So this negative is negative here because of something else. Now this is negative sine pi over 4 because it ends in the third quadrant and it's the opposite of the sine of the reference angle. That's why this turns into positive.
So these are two steps. Let's review these two steps one more time. First of all is sine of a negative angle. So that takes care of the negative angle. So I don't have to go the other way. But now I know that sine pi over 4 ends in the third quadrant. So the answer for that must be negative. So it's the opposite of sine of the reference angle. And that's how we get positive
Sine pi over 4, which is positive the square root of 2 over 2. So we only determine this piece. Now we have to determine this piece. And then put them together. So sine 11 pi over 6. This is again that 30 degrees times 11. So this is 330 degrees. I know it ends 30 degrees shy of 360. Here it is. So this is 11 pi over 6. I know that the reference angle is pi over 6. And then since it ends in the, or lands or has a terminal side in the fourth quadrant, the answer must be negative. So negative sine pi over 6. I know pi over 6 is the smallest angle. It's 1/2 with minus in front, negative 1/2. So finally, I can put everything together now. And I have the square root of 2 over 2 multiplied by negative 1/2, which is the square root of 2, negative the square root of 2 over 4.
So moving forward, you don't ever have to determine three functions of negative angles. Once you remember that there are two even functions and all the other ones are odd. So again, this is a nice table. I really like it, but I hope you're not going to sit down and memorize it. There is no need for something like that. Okay. Let's practice some more. The same idea, everything the same. So here are the typical problems. For the following exercises, find the exact value of each expression. That's a tiny example. This one, use the reference angle to evaluate. That's what we've been doing. And here, these are more interesting problems. So let's take a look. Or we can do anything you want, of course. Yes, please, babe.
It says use a reference angle to evaluate. So
We always use the reference angle to evaluate.
For that one,
Right.
is it just asking to find a reference angle?
The first one, I think it's only the reference angle, but this one says evaluate.
So what does that mean?
Find the answer.
Find an answer.
Yeah, for this one, it's probably asking you, I have to scroll up. For that one, it's asking you to identify the reference angle and potentially just determine. Let's take a look.
They're the same. For the following exercises, find the exact value of each expression. So here, for the following exercises, use the reference angles to evaluate the expression. Because here, they're all in the first quadrant. So the angles in the first quadrant are their own reference angles. But in the next example, they're all over the place. So not necessarily in the first quadrant. So here, you don't have to determine the reference angle if the angle is in the first quadrant. It's a very good question. Because in the first quadrant, the angle is its own reference angle. But anything else beyond that point, beyond 90 degrees, you have to determine the reference angle. Very good question. Thank you. So let's choose. I think that we are beyond that because those are only in the first quadrant, but maybe you want to choose something else.
Now here, let's just see this. If sine, this is very important, so we have to work on a problem like that. If sine t is 3/4 and t is this in the second quadrant, find the other three functions. Very important type of problem. The same thing here. If tangent t is blah 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 and the angle is between 0 and pi over 2, which means first quadrant, find blah blah blah. So we want to practice some more with this, we can, of course. And we haven't done a lot of tangent, secant, cosecant, so we should. And definitely 38, 40, we have to work on that.
Yes. Your preference. Which one? So we want to start with this one. Excellent. Excellent problem. Perfect. So we started with 28 on page 631, and we're asked to find cosecant to pi over 3. Oh, sorry.
No one will ever force me to think in terms of cosecant, of course.
Absolutely. Cosecant 2 pi over 3 is 1 over sine 2 pi over 3. Who cares about cosecant?
Okay, so now I have to find cosine, I have to find sine 2 pi over 3, and that I know that it's 2 times 60 degrees. 2 times 60, 120. So 60 degrees shy of pi. I know that sine length, so the angle length in the second quadrant, obviously the sine will have what sign? Positive, very good. So then sine 2 pi over 3 would be sine pi over 3.
So sine 2 pi over 3 will be sine pi over 3. And that's a nice one. It's the last angle, and it's sine. Yeah. So I put it in here. So the answer is 1 over the square root of 3 over 2, or 2 over the square root of 3, and I have to rationalize.
That's my point. Do not sit and do anything with secant, cosecant, tangent, cotangent. It will take you a length to determine those. Yes, Lauren, go ahead.
Do you have to rationalize? Because like I've
Yes.
never rationalized.
Yes. Do you want me to show how?
No, I know, but
Yes.
I've never had to do that.
Yeah, let me show you. Yes. So if you go back to that, even that table that I am not happy about, you sitting down and memorizing it, all of them are rationalized. To the square root of 3 over 3, the square root of 3 over 3, everything is rationalized. So yes, the answer is yes. Mandatory. Okay, moving on. Okay, I would like us to work on 38. Ready for 30? Do you want to choose anything else from here? Is the idea clear? So never think in terms of a negative angle, because now you know there are 2 even functions and 4 odd functions. Then you can always change into sine and cosine. Don't think in terms of tangent, cotangent, secant, cosecant when it comes to these exercises. It's a waste of time. You can always come up with the answer.
So one more time, will anyone want to choose another, or is it okay? Bailey?
No, I'm good.
Okay. So let's move on to 38 then. Uh, 38. We are given sine t equals 3/4. We are told that t is in the second quadrant. They're asking us to find cosine t, secant t, cosecant t, tangent t, and cotangent t.
Okay, forget about for a moment, forget about what we're asked to determine. We do know
3 trig identities. We just discovered all 3 of them a few minutes ago. The first one was sine squared, I'm going to use t, plus cosine squared equals, excellent. The other one was tangent squared t plus 1 equals secant squared t. And the last one was 1 plus cotangent squared t equals cosecant squared t. Okay. Look at the first one and say, if I ask you, yes, Bailey, go ahead.
We're just saying the trig function.
Stop entertaining and pay attention. Okay. So we want to solve for sine t. If I want to solve for sine t, I will write sine squared t equals 1 minus cosine squared t. And then what will I have to do to find sine? Excellent, take the square root. So I take the square root from the left, I take the square root from the right, and then what do I get? And this is crucial. This is quadratic in sine. So what do I have to write in front? Yes, if I forget, then I do not get what I need to. And of course, what will happen if I wanted to evaluate cosine or find cosine if I'm given sine? So this expression really means I can find sine when I have cosine. But how do I find cosine when I have sine? What would be the formula for that? Exactly. So now I'm going back to my problem. My problem says sine t is 3/4. If I manage to determine cosine, all these are done. I have sine. I know that the angle is in the second quadrant. What will be the sign of cosine then in the second quadrant? Negative. Awesome. So then I can write immediately cosine t equals the opposite or negative, the square root of 1 minus 9/16. So let's go back and talk about this one more time. When we're given sine, they say 3/4. And they say t is in the second quadrant. Find all the other 5 trig functions. The answer would be immediate once I have cosine. Once I have cosine and sine, I determine the other 4. So I know that since the angle has a terminal sine in the second quadrant, the answer must be negative for cosine. And it's the square root of 1 minus sine squared. Of course, I will have 16 minus 9, which is 7. So then cosine t equals negative the square root of 7 divided by 4. I'm sorry? 16 minus 9. I have to find the least common denominator, change this into 16 over 6. I have 3/4.
And why did you square that?
Because that's the formula. It's 1 minus sine squared. And if sine is 3/4, when I square it, I get 9/4.
So you just took sine and you just square it?
That's the formula. We just determined the formula for cosine. So cosine t, if I have sine, cosine t is either plus or minus, not both, of course. In this case, it's negative, the square root of 1 minus sine squared. And sine is given to us as 3/4. When you square that, we get 9/16.
So it's asking from sine of that.
To find the other.
Every other thing.
Actually, we're given 2 pieces of information. We are told where the angle ends, and that's a key item.
Oh, was it the 11 with the 2 bars? Is that what you got by second quadrant or something? What do you have?
Yes. Sorry about that. So t is in the second quadrant. We need to know that information because otherwise we don't know what to choose. Yes. Any questions? Emmy, go ahead. Please.
No.
Yes, Lauren, any questions? Please.
Can't you just draw a triangle and then do the Pythagorean
Yes.
theorem?
Yes. You
Show
can.
it that way?
Yes, I will show that way in a second. Let's finish it up and I'll show you that way too. Absolutely. Okay, so now I have to find tangent of t, which is cosine, sine over cosine. Sine is 3/4. Cosine is negative the square root of 7 over 4. So we get negative 3 over the square root of 7, and we rationalize negative 3 the square root of 7 over 7. The other method, I have to agree, it's a little bit easier, but this is what we're going to be looking at when we have letters, not numbers. So that's why I wanted to show this, but it's a very good point. I will show the other one in a minute. Of course, cotangent t is this one reversed, negative the square root of 7 over 3. And secant t is this one reversed, negative 4 the square root of 7 over 7. And cosecant t is already given to us because I have a sine, which is 3/4, so this is 4/3. So when we have sine and cosine, all the others have no secret whatsoever. And yes, let's look at the other method. Very good point, and thank you for asking for that. Okay, so the second quadrant, and we are told sine is 3/4. So this point, so now this is not the unit circle anymore, okay? So sine is 3 divided by 4. Or you can consider it, that's not a problem. So 3 and cosine. So you just draw an angle in the second quadrant. And this point, so this is your reference angle. So sine of this, and I'm going to call the reference angle alpha, 3/4, the opposite over the hypotenuse. And then you have to determine the other leg, which will be 16 minus 9, which is the square of 16 minus 9, which is the square root of 7. And that's how we get that square root of 7 anyway, same thing. So sine is 3/4. But now cosine is negative because cosine is negative in the second quadrant and the third quadrant. So cosine would be the square root of 7/4.
Would it be negative?
Yes, negative. Yeah, because it's negative. Cosine is negative. And then tangent would be still negative, 3 divided by the square root of 7. And cotangent would be positive, the square root of 3/7. The square root of 7/3. And then secant would be the square root of 7/4 with negative.
Oh, so you're doing this even without knowing an angle?
Yes.
You just have those three sides?
Because we are told t is in the second quadrant. I personally don't like this method, but of course I don't have anything against it per se. I just don't use it. The reason I don't like it is because I have to figure out, I have to determine this anyway, right? But then I may forget signs. That's me. That's me.
Why don't you just plug in the signs right there?
So you just have to remember that since it's the second quadrant, sine would be positive, cosine would be negative. Everything that has cosine in it would be negative, and just sine and cosecant would be positive.
Well,
If you remember that, this method is fine.
well, wouldn't that be avoided if you just put a negative right next to the square root of 7?
You can, but this is remember this is a length.
True.
So in this triangle, this
Technically
is
not.
still yes, exactly. So that's why it's a little bit of a conflict there, but it's a perfect method. I just personally don't use it. Okay, so I know we have 5 more minutes, and let's see whatever else we can look at in one more problem. So let's choose one more problem. So here's where we are. We finished including 7.4. So on Thursday, we're going to look at graphs of sine and cosine functions and also other functions. We're going to mention the trig functions. We're going to look at 3 of them. And then we're going to look at the law of sines and law of cosines. Okay, so let's choose. We have, as I said, 5 more minutes. Let's choose another problem. I like this one, if you'd like, or this one. Here, this is easier. Why is it this easier? Because we can identify the angle. If you tell me that sine is the square root of 3/2, and you're also giving me cosine, then I know exactly which angle it is, because I know the square root of 3/2 and 1/2. So this situation is easier. Now, if you want to look at tangent, maybe we want to start with tangent. This is a little bit more complicated situation, because we're not given sine or cosine. When we're given any other trig function, it's a little bit more work, potentially. So would you like to work on 40? Okay, perfect. So let's work on 40. And then we'll stop. And I want to talk about one thing if you're not in a hurry. But if you're in a hurry, we can wait till Thursday. So 40. And we have, we're given tangent t equals 12 divided by 5. And the angle is nice, which means in the first quadrant. And we're asked to find the other trig functions, sine t, cosine t, etc. Again, yes, you can create that triangle with the two legs, 12 and 5 in the first quadrant, which is fine because all trig functions will be positive. Would you like to go that route? The other option, the one that I prefer, is to use the tangent squared plus 1 equals secant squared. But you can say no, I want to use the previous method. It's up to you.
Which one? The triangle? Okay, very good. So we are told that the angle is in the first quadrant. So whatever angle, this is alpha. It has to have 12 divided by 5, and that's the tangent. We have to determine the hypotenuse. The hypotenuse will be the square root of 144 plus 25, which is the square root of 169, which is 13. Perfect. These are Pythagorean numbers. 5, 12, and 13 are called Pythagorean numbers because they are in this relationship. 5 squared plus 12 squared equals 13 squared. And then the rest is easy then. That's fine. So sine alpha, it's t. I called it alpha, I'm sorry. Sine t will be 12 divided by 13. Cosine t will be 5 divided by 13. Tangent is given. Cotangent is the reverse, 5 over 12. Secant and cosecant. Secant is 1 over cosine, which will be 13 over 5, and cosecant is 1 over sine, 13 over 12. That's quite all right. It's a very good method. I don't have any